So now we're up to Chapter 6, Lesson 4, dealing with compound inequalities. And so a compound inequality consists of two separate inequalities joined by an and or an or. And this is an example here. We've got negative 2 is less than x, and x is less than 3. So 3 is greater than x, which is greater than negative 2 is the easier way of writing that down. So if we were to write this down, it would look like this. You can see it's kind of written down there. So every number that's in this part right here, that is a solution. For this one here, what we've got is we've got two separate possibilities. One is when x is greater than or equal to 3. One is x is less than negative 2. So let's look at this one here. It says here, translate the verbal phrase into an inequality, then graph the inequality. All real numbers that are less than or equal to 7 or greater than or equal to 1. Okay, so they're greater than or equal to 1 and less than or equal to 7. So that's how it would look, and now we're just going to write it down. So I wrote out all the numbers on my number line. Now I'm just going to fill it out. X is less than or equal to 3. So it's filled in. It's a circle there. And it's going to go to 1 here. So that's going to be my line that I have. So everything on this side here and this side here are not a solution. Everything in between there are a solution. Let's look at another one here. So I'm going to look at this problem here. All real numbers that are less than negative 3 or greater than 0. So let's figure that out. X, so x is less than negative 3, or x is greater than 0. Okay, so let's look at that. So here we have it set up. I just wrote the numbers above because I think it's easier to see that way. So x is greater than 0. So x is greater than 0. So that's one possible solution. Or x is less than negative 3. So that's how you'd write out the solution to that. So the only part that is not a solution is going to be right there. So hopefully this makes sense. Again, it's just making sure that you have two of these symbols in your inequality, because you're going to have either a starting point or a stopping point, or two starting points where they go off and raise in the opposite direction of each other. So let's look at one more down here. All real numbers that are greater than or equal to 14. So x is greater than or equal to 14, and x is less than or equal to 10. Okay, so is it possible to combine those things? No, it's not. So let's go ahead and write this out. So here we're just going to go ahead and write this out. X is less than or equal to 10. So less than or equal to 10. And then x is greater than or equal to 14. So that's the solution. So let's try another couple here. For this one here, we can solve these in a different ways. So let's look at this. We can solve them as two separate inequalities. So 7 is greater than or is less than or equal to x minus 4. Let me rewrite. So I broke that down into two separate inequalities, and I'm just going to add 4, end up with x is greater than or equal to 11. And over here I'm going to add 4 again, add 4, end up with x is less than or equal to 16. So you can see I wrote down all those numbers, kind of bunched together, but still. X is greater than or equal to 11, so that's going to be a filled-in circle. And x is less than or equal to 16, so it's going to be like right there. Connect the dots. So everything in between there is a solution. Is 14 a solution? Yes, it is. So I'd like to check those to make sure. Same thing is going to happen with this problem here. Quickly going to do that. So in this case here, we're going to solve the inequality by subtracting 4 from both sides and then dividing by 3. And for this one here, we're going to add 12 to both sides and then divide by 5. And what we'll end up with is, if you can visualize this, figure out the math, it's going to end up with 3x is less than 12. Just subtracted 4 from both sides, and x is less than 4. Then over here it's going to be 5x is greater than 25. X is greater than 5. Then we're just going to graph that. Okay, solve the inequality for these solutions. Yet one thing you can do with something like this, if you want to, you can add, or you can go ahead, and if it's this compound inequality where there's just an x or a variable expression in the middle, then you can just treat all the sides as if you subtract 3 from both sides and then divide by 2. So let me show you what I mean by that. If I add 3 to all sides of this, it's going to be 12. Or if I subtract 3, actually, let me correct myself. If I subtract 3 from all sides of this, it's going to be 6 is greater than 2x. And then I have to subtract 3 also from the 15. 12. So all I did was I subtracted 3 from all sides. Now I'm going to divide all the sides by 2. So it's going to be 3. And that's going to be my solution. Now, in terms of if this was a negative 2x, you'd reverse every single one of the inequalities if you were dividing by negative 2. So let's look at an example of that here. If we can find one here. So yeah, so this one here. The first step is going to be to add 12 to all sides, so it's going to be 42 is greater than or equal to negative 7x, which is greater than, and we're going to add 12 to that as well, so it's going to be 28. So all we did was we added 12 to both sides. Now we're dividing all the sides by negative 7. So now it's going to be suddenly negative 6 is less than or equal to x, which is less than negative 4. So you see how I switched the inequalities in the direction to make sure that they actually, because I'm dividing by a negative number. I'm dividing by negative 7 in that case. So same sort of idea here for these ones here. For this first one here, I would add 7 to both sides and divide by 3. And for this one here, I would subtract 4 from both sides, and then I'd divide by negative 1, and I'd flip the inequality symbol. For here, the first step is going to be distributing that 4, and then after that, just following through with the rest of the steps. So let's move on to a couple more, to one last problem here. At an auction, the lowest bid for an autographed trading card is $20. The highest bid is $54. Write and graph a compound inequality that describes the possible bids. So x, the lowest bid, so it's going to be like that, is that. The highest bid, so if I were to write this out, what I'd do is it would be like this. And then it would go in that direction to 20. That would be my compound inequality solved. All done.